Excellent. You have arrived. The last lesson of our series on physical behavior of matter. I'm going to cover the combined gas law. So we're going to use some math today. I'll be at the board, right? Okay. This combined gas law relates temperature, pressure, and volume for gases under different conditions. So it's always a before versus after scenario. And that's what I want you to keep in your mind as you're working through these problems. Before versus after, constants don't change. If it's a sealed container, we can figure out what our missing variable is. Okay, so before and after sealed containers, temperatures always have to be in Kelvin because we need our temperature values to be positive numbers. We can't have negatives here. Pressure and volumes may vary as long as they stay uniform, aka same on both sides of a reaction, or equality. We'll be solving equalities, yes. The combined gas law is written on table T, and it looks like that. But it means ones are before, twos are after. So the pressure times the volume divided by the temperature is equal to the pressure times the volume by the temperature 2. So before equals after, okay? And 1 is the initial, 2 is the final. So here's some example problems. Got to do some math here, do some rearrangements on the board, and you'll do the mathematics of solving these problems and then doing your practice, okay? So start with our equation here. P1 V1 over T1 equals P2 V2. P1 V1 over T1 equals P2 V2 over T2. So we look through our problem, we find out what our volumes, temperatures, and pressures are. So the volume of the sample is at 273, temperature 1, 0.5 atmospheres, pressure 1, 150 mils, volume 1. The volume is decreased to 100 mils, so there's volume 2. At pressure of 3 atmospheres, there's pressure 2. What's the new temperature? Well, T2 is our unknown. So let's put our variables in and see what we got. Pressure 1, 5 atmospheres, times volume 1, 150 mils, divided by temperature 1, 273 Kelvin, equals, well, we have our volume 2, our pressure 2, and we don't know our temperature 2. So volume, pressure, there we go. 3 atmospheres for pressure, volume 100 mils, and the temperature is in X Kelvin degrees. Now to solve for this particular problem, we have to isolate X by itself. Not actually that difficult to do, okay? The way I like to do it is I just start solving the problem. Okay, and I'm going to say here, I'm going to take a shortcut and write out the problem. X is going to equal 3 atmospheres times 100 mils times 273 Kelvin divided by 5 atmospheres times 150 mils. Well, I did that. I got there because I can rearrange the equation. If you have to use cross multiplication to solve for X, you go ahead and do it. Okay, let's keep on going with some examples. You solve the math, by the way. Let me erase all this stuff and get to the next question. We're going to use the same P1 V1 T1 over P2 V2 T2, but we're going to have different variables. So we got to look through our problem and find out what those are. Okay, a gas has a volume of 4 liters. Volume 1, 346 Kelvin, temperature 1, 2 atmospheres, pressure 1. So I'm going to set that one up. 2 atmospheres times 4 liters over 346 Kelvin is equal to, we got to find new volume. So we're going to volume 2 equals X. Temperature is 273, so that's temperature 2. And pressure is 1 atmosphere, pressure 2. So the volume 2 is X times pressure 2, 1.0 atmospheres, divided by temperature 273 Kelvin. I'm going to rearrange to solve for X by itself. It's pretty straightforward to do. X is going to equal, let's see, well, that's easy. 2 atmospheres times 4.0 liters times 273 Kelvin divided by 346 Kelvin times 1.0 atmospheres. And that will give us our final volume. Okay, you will solve that math. The only other couple ways that these problems show up, and again, we're going to be solving for the one missing variable. The hardest part here is finding your 5 variables that you know, and then solving for the one that you don't know, because it requires algebra. Okay, finding the final pressure given the final volume and temperature. Again, I have to use the same equation, P1 V1 T1 over P equals P2 V2 T2, because that is the combined gas law equation. I'll help you find your variables here. 20 mil sample, that's volume 1. STP, well, that's 1.0 atmospheres and 273 Kelvin. It's heated to 398 Kelvin, so that's temperature 2. What's the final pressure if the final volume is 100 mils? Oopsies, I disconnected my board here. Stepped on the wrong cord. Boom, hopefully that'll work. Doot doot. Doot doot. Doot doot. Let me try this here. So we're going to set this problem up the same way. Boop, boop, boop. Hopefully these are working. 100 mils. Nope, it's not working. Okay, which means you have a challenge to do this one yourself. Technology doesn't always work. Sorry, it failed on us. But you've got your work cut out for you. Find the 5 variables. I already helped you identify them. Set up it, solve for X, and you've got your answer. Okay, and that would be all. Okay, this combined gas law, I know it's going to be a stumbling point because of algebra and reading the problems to find the variables. Okay, that's why there's plenty of practice on it. It's the last lesson in the whole unit. Okay, so the whole unit we've covered heat, how it flows, changing temperature, heating and cooling curves, and labeling and identifying changes in energy. We've covered the behavior of gases. We've covered the behavior of what it means to boil something. And we've also covered the combined gas law with the algebra of before and after on a gas, okay? How changing pressure, temperature, and volume will allow you to predict the unknown variable for the temperature, pressure, or volume, whichever one's missing when you've got it all done. So I'll see you next unit. We're going to go from physical behavior of matter to solutions, okay? So how liquids behave when you've put something into them. So we've covered gases. Next unit's basically liquids plus a little something else. See you then. Bye-bye. Button, and I'll turn off the video.